Kia ora koutou, Reese from QuickSense here, and today we're looking at trigonometry problems in 3D. Now this figure is giving us a cube with side length 5, and it's wanting the angle HBF. So that angle is HBF. Right, so we're looking at this angle up in here. So the way I'm going to go about answering this question is actually in two parts. To find the angle at once, which is between H, B, and F, right? I already know what BF is, right? That's 5. That is this line here. But I don't know either this, let's call this X1 or X2. I don't know either of those. But I can see a right angle triangle. I'll try and draw a little right angle there. I can use that to find X2. Perfect. So that's 5. That's 5. Right, we've got 5 and 5. So this is X2. We'll do that in blue. And it shows up here as well. So X2 is C. So it is equal to the square root of 5 squared plus 5 squared, or the square root of 50. We're going to keep it like that for the moment. So now I've got the square root of 50, 5, and x1. So x1 equals the square root of 5 squared plus the square root of 50 squared, which is equal to 25 plus 50, or the square root of 75, or 8.67 centimeters. In this next question, we're going to try and solve it despite the fact that we're not given any numbers. So instead, we're going to think about these lines, so as their own sort of thing. Right, we're going to give them values. Okay, so we can just say that the size of this cube is x. Yeah, so any value we use is going to have some form of x in it. So looking at this, it wants angle DXB. Now immediately, I am drawn to a straight line making the triangle. This might be helpful later. D, B, and X with that angle in the bottom, which is what we're trying to find. Now I can see that DA, AB, and DB makes a right angle triangle. Right, it looks like this. X, X, something. So this is going to be DB, which is the square root of 2x squared equal to the square root of 2 lots of x. Put that up there as well. Oop. I want to be clear, this is the square root of 2 times x. So what does that help us with? Well, we can use this value here, the dB, to make another triangle, right? This diagonal is going straight through the middle. It's obviously not to scale, But h to b, that's going through the middle. And so this space here let's do this x slightly differently, is half of this space here. And we've got another right angled triangle. This right angled triangle looks like this, square root of 2 times x, x over here, so HB is equal to the square root of 2x squared plus x squared equal to the square root of 2x squared plus x squared, or after we simplify this down, right, it'll be the square root of 3 times x. And as we can see from up in the top here, this goes through the center, so h or xb must be equal to half the square root of 3 over 2, square root of 3. X equal to the square root of 3 over 2 x. Okay, and because we're dealing with a cube, dx is equal to xb. So it's passing through that same point. So that's also going to equal to this one here. Seeing this triangle now on the top right, I have 1, 2, 3 sides, and I'm trying to find an angle. So what I'm going to do is I'm going to use the cosine rule. And with the cosine rule, I'm going to be able to solve this problem. So the cosine rule, remember, is c squared, where c is opposite. Right, so c is this one here, it's opposite the angle. A squared plus b squared minus 2ab cos theta. You have to be careful with space on the right hand side. Let's just demarcate. All right, substituting in. C is the square root of 2x squared equal to 3 over 2 x squared. We're probably going to run into the second line. That's okay. Square root of 3 over 2 x squared minus 2 lots of 3 over 2 x. And we're timesing them together, so I'm going to take a little shortcut here and square that immediately. Cos theta. Right, I'll just repeat that. I can do this because a and b are the same. A times b is just a or b squared. So let's simplify this a little bit. Right, square root of 2 squared, 2x squared. This becomes 3 over 4x squared. So we can even simplify that further. 3x over 4 plus, we're doing it again, 3x over 4 minus, right, 2 lots of, we've got 3 over 4, or 3x over 4. We can change that, simplify that. Minus 2 times 3 gives us negative 6x squared over 4 cos theta. So we're simplifying as we go there. So what I'm going to do now, I'm going to simplify. I've got 2 lots of 3x, right? So that's 2 lots of 3x over 4. 2 cancels out with that 4, right? So it leaves me actually with just a 2 on the bottom, which is what we started with, right, which is quite nice. So minus 6x squared. And we can cancel out this one here, right? We've got a common factor of 2. Right, so that goes into that 3 times and that 2 times. Okay, so now we've got 2x squared. I'm going to subtract 3x squared over 2 from there equal to negative 3x squared over 2 cos theta. I can simplify on the left-hand side. Right, we can think of 2x2 over 1 and make it have the same denominator, which gives me 2 on the bottom times the top by 2. 4x squared minus 3x squared is 1 lot of x squared. So that leaves me with x squared over 2 equal to 3x squared, negative 3x squared over 2 cos theta. With a bit of rearranging now, right, times both sides by 2, etc., etc., this leads me to theta equal to inverse cos, we're running out of space now, aren't we, of negative 1/3. Alright, so let's pull that over here. So my calculator is a bit weird, it doesn't like me doing negatives. So what we're going to do is 1 divided by 3, we're going to make it like that. Make it a negative, inverse cos, and we get approximately equal to 109.47 degrees. What a marathon. But we got there by using Pythagoras and then using the cosine rule with a little bit of algebraic jiggery-pokery.